Science processes and attitudes. You have likely built a bonfire while camping. First, you pile dry wood or cut branches at the center of your campsite. Add kindling or extra fuel to help it catch fire. Then use matches or a lighter to ignite it. In moments, you have a steady, warm fire. Every step of this familiar activity follows scientific rules: how fuel burns, what materials are needed to start the reaction, and how friction from striking a match creates enough heat to light the flame. Still, the full science behind combustion took centuries to work out. Early societies had no idea oxygen existed, or that it plays a critical part in making things burn. In 1703, German professor Georg Ernst Stahl put forward the phlogiston theory to explain what was happening. He argued that all things that can burn hold an invisible substance called phlogiston, which escapes into the air as the material burns away. Once all the phlogiston had been released, the leftover ash or solid remains were called calx. This idea was widely accepted and used to explain burning for well over 100 years, before later experiments proved it was not quite correct. A theory is a set of explanations and organized principles put together to explain a specific observed phenomenon. While a theory gives us a clear way to understand how or why something happens, it is not an absolute, permanent truth. What we accept as a good explanation today may be revised or replaced as we gather better evidence and new discoveries emerge. This is exactly what happened to the phlogiston theory. It was eventually proven wrong because scientists found that the supposed substance phlogiston did not actually exist at all. It was French scientist Antoine Laurent Lavoisier who corrected this understanding. He clearly showed that the combustion process does not release some hidden substance. Instead, it depends entirely on oxygen gas from the air. His careful work and breakthrough explanations earned him the well-known title, Father of Modern Chemistry. The idea that oxygen is required for burning is now considered a scientific fact. It can be directly observed, measured, and tested over and over again by anyone with consistent results every time. Studying how ideas like these change teaches us an important skill. We should never accept information or claims without thinking them through. As Albert Einstein famously said, "The most important thing in this world is not to stop questioning." Whenever we hear a new claim, we should ask questions, look for solid proof, and check if it holds up against testing. This critical thinking helps us clearly tell the difference between what is proven scientific fact and what is unproven rumor or false hoax. Decision-making based on logical reasoning and careful judgment is a core science process skill. Mastering these inquiry skills, applying scientific knowledge, and building the right scientific attitudes and values together form essential 21st century abilities. Scientific literacy, technological literacy, and environmental literacy. Important science process skills: asking questions, observing, communicating, comparing, classifying, measuring, formulating hypotheses, inferring, predicting, designing investigations, collecting data, analyzing data, interpreting data, drawing conclusion. A scientist is an expert in one or more fields of science who carries out systematic research and investigations. Beyond these practical skills, scientists also hold scientific attitudes, the core values and habits of mind that guide good science. 1. Accuracy. Collecting and recording data that matches true, correct values as closely as possible. 2. Curiosity. Having a strong desire to learn, ask questions, and explore how and why things happen. 3. Creativity. Thinking of original ideas or finding new, better ways to solve problems. 4. Critical mindedness. Examining facts carefully and making fair, well-supported judgments. 5. Humility. Being modest, willing to admit what you do not know, and open to help or feedback from others. 6. Initiative. Taking action independently without waiting to be told what to do. 7. Innovativeness. Turning new ideas into practice or creating things or methods that did not exist before. 8. Intellectual honesty. Being completely truthful in all work and never hiding or altering results to mislead others. 9. Objectivity. Focusing only on facts and evidence without letting personal feelings or preferences affect your work. 10. Open-mindedness. Listening fairly to other people's views and ideas and considering them thoughtfully. 11. Perseverance. Staying determined and keeping going even when you face setbacks, hard work, or failure. 12. Resourcefulness. Finding ways to overcome challenges or making good use of whatever tools or materials are available. 13. Responsibility. Putting full effort into every task and doing your best work even when no one is watching. 14. Risk-taking. Being willing to try new ideas or approaches even when they may not work or bring criticism.